2.3 local minima, maxima, and rate of change. So a function f has a local maximum at c if there's an open interval I containing c, so that for all x unequal to c in I, f of x less than or equal to f of c, we call fc a local maximum of f. Well, that's a mouthful. What does that really mean? Well, it means the following. If I look at this graph over here, and I'm looking at an open interval, that's why we have these things over here, this point is called a maximum as long as the points immediately next to it are both less than it. So if I'm comparing it, all of the points immediately to the left or to the right are less. For a maximum, one way that you can recognize that is that the function is initially increasing, it reaches a maximum, and then it's decreasing. The minimum is sort of the same thing, but then instead of increasing to decreasing, it will go from a decreasing part of the function to a minima, and then it goes to increasing again. Okay? It's pretty easy to spot in the graph. So let's look at an example and see what it looks like. So here's a graph, and we want to find a local maximum, or if there's more than one, you need to find all of them. Well, right here is a hump, and there's a top to that hump, so that is a local maximum. So there is a local maximum at f1. That maximum is 2. Okay? Notice the graph, it goes from increasing to decreasing. Local minimums. We have 2. We have 1 right here. So there is a local minimum at f is a -1, and that minimum would be 1. And there is a local minimum at f3, and that minimum would be 0. So it is possible to have more than one minimum. In this particular case, this point over here can also be called an absolute minimum, because the graph does not go lower than that at any point, right? Whereas with the maximum, yeah, here it's the highest point, but clearly over here you have points on the graph that are way higher than 2. Okay? So let's look at the increasing, decreasing intervals. So remember, for intervals here, you would just use the x values. So it's increasing starting at a -1, and then it increases up to until x is 1, and then it starts to increase again at 3, and then the graph is increasing until infinity. Keep in mind that this references only the x values, so the fact that -1, 1 is a point, that's not this -1, 1. Okay, this one here is an x, so the interval goes from x starts at -1 and runs until x equals 1. Okay? How about decreasing? Well, the graph is decreasing when x's are super negative. Okay, so if you're at a -100 and you go to the graph and then you look at a -99, because keep in mind that for decreasing and increasing we would look at x1 and then x2 has to be bigger, then the graph would be decreasing. So negative infinity up until, not 2, sorry, until the -1. Then it's increasing, then it's decreasing again, starting at 1 and ending at 3. And again, those are x values. Alright, average rate of change. So average rate of change, and it gives you some more words over here, but it's defined by this little formula here. That is pronounced as delta. So it's defined by delta y divided by delta x. And that is the value at b minus the value at a divided by the b minus a, the values that you plugged in. So what does that look like? Well, if I need to find the average rate of change of a function, that's a half x, then I would first have to figure out what happens at 0 and what happens at 1. Well, at 1 we would get a half. And then for the average rate of change, I'm going to fill in that formula. Okay, so the average rate of change would be fb, so I'm going to use this as point b, so it's a half minus 0 divided by 1, that's the x value I used to get that half, minus 0. So a half divided by 1 is a half. From 0 to 3, what would be the average rate of change? So f3 would be a half times 3 squared is 9, so that's 9 over 2. So the average rate of change would be 9 over 2 f of 3 minus f0, which I still have, divided by 3 minus 0. So that's 9 over 2 divided by 3, which means that you would have to do 9 over 2 times 1 over 3. Those cancel. So finally we end up with 3 over 2. And then finally, if I do it again from 0 to 5, what happens there? So from 0 to 5, at f5 you would get 25 divided by 2. So the average rate of change would be 25 over 2 minus 0 divided by 5 minus 0. So we're going to flip that fraction right away. Those cancel, so that answer is 5 over 2. Okay, average rate of change should look very familiar, okay, because if I translate this a little bit, and I did mention this a moment ago, I said f of b is a y value. So let's call that the second y value, and that's the first y value. This was the x used to find y2, and this was the x used to find y1. So I could rewrite this as y2 minus y1 over x2 minus x1. So average rate of change is actually a slope. Okay? Sorry, I should have just spelled out slope. Well, what is it the slope of? Well, it's the slope of a concept that we call the secant line. And the secant line is a line that connects 2 points that are on a graph. So these 2 points are connected with this straight line. And then the secant line here has as its slope the same value as the average rate of change that you would get if you used A, FA, B, and FB. Okay, because again, keep in mind that these are subtracting y values. So FB could be seen as y2 minus y1, and then this would be x2 minus x1. So let's use that in context. So here we have a function. Find the average rate of change of g from a -2 to 1. So we need to do f -2 first, okay, which would be a -2 times a -2 squared plus 4 times a -2 minus 3. So that would be a -19, right? That's 4, -8, plus a -8 is -60, minus 3 is a -19. F1 would be a -2 times 1, it's -2, plus 4 times 1, which is still 4, minus 3, so that value would give you a -1. So the average rate of change would be FB, which this is FB, so -19 minus F1 divided by B minus A. So a -19 plus 1 is a -18 divided by a -3, so the average rate of change is 6. Okay, now write the equation of the secant line containing those 2 points. Keep in mind that I just found the slope of the secant line is the average rate of change, so the slope of the secant is 6. Well, then let's just use this point, and I know that at 1 I get a -1, so that's easier the 2 points to use. So I'm going to use y minus y1 is the slope times x minus x1. So that ends up being y plus 1, because minus a negative, is equal to 6 times x minus 1, and you can leave that. And that's it. Thank you.